you can use binomial expansion to find approximations of certain values. And by working through these examples, I'll show you how this works. So, example 1, we are required to find the first three terms in ascending powers of x of the expansion of 2 minus x to the power 5. And then by setting x to be equal to 0.01, we are required to use our answer to find an approximate value of 1.992 to the power 5. So I'll work out this question in two steps. The first step will be to find basically the first three terms in the expansion of 2 minus x to the power 5. So step 1, find the first three terms. This is three terms in expansion of 2 minus x to the power 5. So let's assume this is a non-calculator question, which means we are required to use Pascal's triangle to find the binomial coefficients. And you can always produce Pascal's triangle. I've already discussed in the previous videos how to do that. So because n is 5, these will be our binomial coefficients. Okay, so back to the question. We just want the first three terms, which means so basically 2 minus x to the power 5 will be equal to, the powers of 2 are descending, so we start with 2 to the power 5 plus the binomial coefficient is 5. Remember, our binomial coefficients will be 1, 5, 10, 10, 5, 1. So because we just need the first three terms, these are the ones that we'll be focusing on. Okay. Anyway, so here we'll have 5 into 2 to the power 4, negative x to the power 1, plus 10 2 to the power 3, negative x to the power 2, plus of course other terms that come after that. And if we simplify this, that will be 32 minus 80x plus 80x squared, plus of course what comes next. So those are the first three terms in the expansion of 2 minus x to the power 5. Now step 2 is, if x is equals to 0.01, we need to find what this gives us. So step 2, if x is equals to 0.01, this gives us, so we're just going to plug 0.01 in place of x. And by the way, this expression will be 2 minus 0.01 because we are letting x to be 0.01. So that 2 power 5 will be equal to 32 minus 80 multiplied by 0.01 plus 80 multiplied by 0.01 squared plus whatever comes next. So anyway, this will be equal to 31.208. Okay, if you plug in your calculator, that will be 31.208. Now, just remember that this is equivalent to 2 minus 0.01 is actually 1.99 to the power 5. Okay, which is basically what we are required to approximate here. Okay. In this example, we are required to expand a plus 3x to the power 5 and then find the value of 1.03 to power 5 correct to 5 decimal places. So the first step will be the expanding, and we shall use Pascal's triangle. So from the Pascal's triangle, we can see that our binomial coefficients are these ones here. So we shall just write them over here, because I'm assuming this is a non-calculator paper. Could be a calculator paper as well, but you need to know that different ways of getting binomial coefficients. One way is using the Pascal's triangle. Okay, so back to the question. Since we have the coefficients, we can go ahead and expand a plus 3x to power 5. So what we shall have is this will be equal to a to power 5. Remember, the powers of a are descending and the powers of 3x are ascending. So 5a to power 4, 3x plus 10 a to power 3, 3x to power 2 plus 10 a to power 2, 3x to power 3 plus 5 a to power 1, 3x to power 4 plus 3x to power 5. And then we have to simplify those guys. Now, if we simplify them, what we shall end up with is a to power 5 plus 15 a to power 4x plus 90 a cubed x squared plus 270 s squared x to power 3 plus 405 ax to power 4 plus 243 x to power 5. So that's the expansion of a plus 3x to power 5. Step 2, and we want to rewrite 1.03 to power 5 into a form that can help us to use this expansion to approximate the value of 1.03 to power 5. So step 2, write 1.03 to power 5 as 1 plus 0.03 to power 5. That way we can be able to compare this expression and this expression. Okay? In fact, by inspection or by comparing corresponding terms, we can notice that a is equals to 1 and 3x is equals to 0.03. So basically what I'm saying here is that by comparing corresponding terms, notice that 3x is equal to 0.03, which means x will be equal to 0.01. And something else, by comparing those two, we can notice that a is equals to 1. So if we know that x is equals to 0.01 and a is equals to 1, we can use the expansion of a plus 3x to power 5 to actually approximate the value of 1.03 to power 5. Okay, so that will be our step 3. So step 3 will be Find the approximate value of 1.003 to power 5 to 5 decimal places. So step 3, find the approximate value of 1 plus 0.03 to power 5 to 5 decimal places. So all that I'm going to do is to replace a with 1 and x with 0.01 in the expansion above. So what we shall end up with is 1 to power 5 plus 15, 1 to power 4, 0.01 plus 90, 1 to power 3, 0.01 squared plus 270, 1 to power 2 multiplied by 0.01 to power 3 plus 405 multiplied by 0.01 to power 4 plus. Now, if you notice that as the powers of 0.01 get higher, we end up with smaller and smaller numbers. In fact, we can say that as 0.01 to power 4, now as the powers of 0.01 get higher, for example, 0.01 to power 4 will be equal to 0.0000000. How many zeros? 1, 2, 1, 2, 3, 1, 2, 3. Yeah, that's an extra 0. So somewhere there. So what we have here is actually a smaller, very small number. In fact, what we are trying to approximate is to 5 decimal places. Now, if you count this number of decimal places, they are beyond 5 decimal places. And so we can ignore the remaining terms as they are less significant. So what I mean is, as 0.01 to power 4 is equals to that, and we need an approximation correct to 5 decimal places. We can ignore the remaining terms. As they are less significant. As they are less significant. Okay, so that's the whole idea. Yeah, we can ignore the other terms after that because they are less significant. So we just need to plug this in our calculator, and if you plug that in your calculator, what you shall end up with is 1.15927405. Okay, so already you can see that we just wanted our answer to 5 decimal places. So basically, this is actually beyond what we want. Yeah, so we'll have to cut off at 7. So our answer will be 1.15927.